So hello everyone. So today we will talk about the definition of tangent line with the slope m. So through two different videos about different quotients, so you learn that different quotients equal to fx plus h minus fx over h basically, right? And then I'm going to briefly review what this means. So basically, now we have maybe one curve like this, and I'm gonna just set up this is my x value. Then, wherever I kind of determine another x, so maybe this part here, x2, I'm gonna say x1, then you know that the difference between x1 and x2, right? This value we define h basically. Therefore, instead of writing fx1 and fx2, we write basically fx1 plus h. That can determine another point notation basically. Then, in this case, we know the given function and then the value h, then we can find the slope. Therefore, the different quotient means finding the slope of 2 points basically. And then we also learned that whenever you want to find out slope, then we need at least 2 points, right? And then that's why we usually dealing with 2 points and different quotient, also the formula to find the slope here. Okay. Then now we want to actually talk about definition of tangent line with slope m here. Then what does tangent line means? So tangent line means whenever we have any object, it can be just circle or curve, something like this, then we defined any line intersect exactly 1 point. So exactly 1 point. So that's the line we just call tangent lines. Okay? But here's one thing I have to say that, so which means its definition, it is not possible actually. What's the reason? Because whenever we want to find out the slope, we need 2 points. But why tangent line slope? We always define passing through 1 point. So through the graphic program activity, then we want to double check what this means. So let's go to GeoGebra program. So I generate one function here. So fx equal to x cubed minus 3x squared plus 3 here. And then I I made one fixed point, which is 1, 1. And I made one point which can moving. So it can be on the positive side, and then I can move this one here, then it can be on negative side as well. Okay? So please remember that based on fixed x value, the h value can be either positive side or negative side. Yeah, it is possible h can be negative as well. Okay? So then now I also set up the slope value here. Then now look at, so because this is a secant line, so secant line means whenever any polynomial functions, so we want to find out the slope of any 2 points, right? So whenever we get close to, so far it is really obvious. It can be 2 points, and then we can find slope, and then as you see this value, it is always various. And then even I'm moving kind of positive side as well. So the slope value kind of varied. So like this, at least we know one fixed x value and the interval of the other x value. Then we always find the secant line slope. Then how to define tangent line slope? Which means we have to find only one point with a line here, right? Which means A and B, those two points must be in the same position. However, if it is actually in the same position, we cannot find the slope because it's only one point. So instead, now what if B is really close to A? So now I'm gonna just moving, because B is on the right side, I'm gonna moving to A here. Then so A here, let's keep on moving. I'm gonna zoom in more and going toward that A. So keep on moving. So as you see, B's keep on moving here, right? So you only look at maybe this point. Okay. So now as you see the y value, even though this still change, but it is approaching 1 and basically 1, and then it looks like slope is approximately -3. Okay, so do you see B is moving toward the A? Yeah. Okay. Yes. So it's really close. I'm gonna zoom in a little more. Now, yeah, so 1.0076 and 5, 4, 3, 2, zoom in a little more so we can see some gap. So you see the simulation better. Okay, now it is moving. So now I can say the slope become -3 based on the simulation, and then when it become exactly same point, do you see slope become defined? Yeah, that's what I'm talking about before. You know, we cannot define the slope with one point. We need minimum 2 points to determine the slope here. So if I make a very small gap, again, I'm gonna moving a little bit right side, one more point. Then now we have slope here, almost -3, but just making exactly 1, then undefined here. Even on the right, on the left side, I can make just a little bit smaller than 1, then we can find out slope, but not exactly same position here. So through the last chapter, we learned about the limit. So in this case, we can define to 2x value gap is almost 0, but obviously it cannot be exactly same the value. That's the reason tangent line slope we have to define as limit, because we need 2 points. So I want to redefine what tangent line means basically. So tangent line, which means still the slope between 2 points where two axis difference is almost 0. That's what I want to say. Okay? It is not exactly 1 point. That's not possible. We need 2 points. Therefore, so using different quotient, so tangent line slope must be defined as limit. So limit here. So their gap h almost 0. So going to the 0, and then f different quotient, which is the f x plus h minus f x over h. So this is the basically definition of tangent line slope. Make sense to you? Okay. So that's all for this video. Then we want to solve some example from the next video. Thank you.